All right, good morning, you guys. Today we are taking on the building blocks of geometry just a little bit more. There are some common clarifying questions that come up that I wanted to address just by going over these four problems. So first up, I'm giving you a visual. So here we see a line, and I've listed 3 points. I've marked 3 points on that line. So my question is this line DO, so if I name it DO, double arrow on top, is that line the same as line OG? So OG, double arrow on top. So here we're just saying that we have two different notations. Does it name the same line? Well, yes, it names the same line. Let's start there. Okay, we know that when we have a line, it's made up of really an infinite number of points that fall on that line. So when we're naming a line, we can name a line using any 2 points that are on a line, any collinear points. Okay, so yes, DO is the same line as OG. We have that double-sided arrow on top. So yes, same line. You can name a line using any 2 points on the line. Those are collinear points. Any points on the same straight pathway are collinear. So since I have 3 points on the line, there's really 6 ways I could name this line. So I'm just going to write that it's the same line no matter if I name it DO, double arrow, or OD, double arrow. I could also name it OG, double arrow, GO, double arrow. I could also name it GD, double arrow, DG, double arrow. All of those are the same line. So when I name a line, I can use any 2 points. Those points would be collinear. They're on the same straight pathway. And in my visual here, I could really name it 6 different ways. I'm just picking any 2 points. Order doesn't matter. I put that double-sided arrow on top to show that it extends in both directions forever. Okay, question 2. Which angle is angle B? So here, this is meant to be a sneaky question. So let me write that. Sneaky question. I am intentionally being sneaky. So think about this for a moment. Look at that picture, and if I said, which angle is angle B, which one do you think it is? Do we mean it to be this angle, this small angle right on top, this small angle on bottom, or this large angle right here? Right? It's not clear. So my answer here really is none. None of these angles are angle B. That's a bad notation in this instance. So I'm going to say none. You can only use this notation if exactly two rays have the common endpoint which is the vertex. So if instead, let me find a slip of paper, if instead my picture looked like this, if I didn't have this extra ray right here, let me cover it up. If my angle looked like this, I could absolutely call it angle B, no problem. But with this extra ray in the mix, now it's confusing. I don't know which angle is meant to be angle B. Is it meant to be this one right here, or this one right here, or this one right here? I really need a different notation to clarify. So we would use a 3-point notation with the vertex in the middle. Or we would use a number in the interior. Let me give you an example. Okay, so again, we could use a 3-point notation. So in my visual, if I meant this one right here, I could have named it ABR. I could have said RBA also, that would be the same angle. Okay, if I meant this one down here, I could say RBK. But again, that's the same angle as KBR. That's just another way to name it. And then the last angle, this big one right here, I can name it ABK. Or I could have named it KBA. So when I use that 3-letter notation, the 3-point notation, the vertex is always in the middle. Okay, another way I could name an angle is with a number in the interior. So imagine my picture looked like this instead, just like that. I can name this angle, angle 1. I can name this one angle 2. That would be fine. It's just another way to name an angle. All right, next clarifying question. Slide it on up. Are points T, A, and P, are they collinear or coplanar? Explain. So let's just tackle one at a time. So collinear. Collinear means points are on the same straight pathway. They're on the same line. Remember, it has the word built into it right there. So are points T, A, and P collinear? Are they on the same line? Yes, absolutely. So yes, collinear. Because points are all on the same line. Okay, so absolutely collinear. Points are on the same line. What about coplanar? Also has the word plane built into it. So are the points on the same plane? So if I take a straight pathway, if I go back to my toothpick, if I slice through a piece of paper like this, are those points on the same plane? Well, yeah, they're on the same plane. What if I tilt my paper like that? Same plane? Yeah, still on the same plane. What if I tilt it like this? Same plane? Yes, same plane. No matter how I rotate my plane, right, I have all these different planes that would slice through those collinear points. So that's what I'm trying to show you, is that points on the same line, they're still on the same plane. The issue comes, which plane are you talking about? You talking about this plane? You talking about this plane? You talking about this plane? I couldn't name which plane until I have 3 non-collinear points. But I know that any collinear points are coplanar too. Let me try to write that in a clean fashion. So I'd say first, yes, the points are coplanar too. But the issue is we don't know which plane. Right? There are technically an infinite number of planes that contain those points. Okay, so points on the same line are collinear, and these points are definitely on the same line. How about points that are collinear? Are they also coplanar? Are they also on the same plane? Well, yes, they're on the same plane. Technically, there's an infinite number of planes that would contain those points. So let's say that I hold my little toothpick like this, right? I have this plane that would contain them. And I could just rotate around, right? Another plane, another plane, another plane, another plane, another plane. There's really an infinite number of planes that could slice through these collinear points. So collinear points are coplanar too, but we couldn't identify which specific plane we're trying to identify. There are an infinite number of planes that contain those points. All right, lastly, is ray CA the same as ray AC? Okay, so ray CA, this would be the endpoint, and it would shoot through point A as it goes in this right-hand direction forever. So this is CA, ray CA, and then ray AC, this would be the endpoint, and it would pass through point C as it goes in this direction forever. So this would be AC, arrow on top. So we can see that they are not the same ray. So no, not the same ray. They have different endpoints. And extend in opposite directions forever. Okay, they do share a little overlap between C and A. That segment they do share in common, right? Segment CA, but otherwise they go in opposite directions forever. Okay, one other thing I just wanted to remind you of, just another piece of vocabulary. I wanted to remind you about opposite angles. I'm sorry, not opposite angles. Opposite rays. Opposite rays. Good, I caught myself before I wrote it. Okay, opposite rays. So opposite rays, they have the same endpoint and they shoot in opposite directions forever. So in my example here, if I look at where A is, I can see that I have this ray right here. This would be ray AC. And here where A is, if I go in the opposite direction here, that's where the T is, this would be ray AT. So opposite rays would be AC and AT. They have the same endpoint. Same endpoint right there, point A, but they extend in opposite directions forever. Okay, so hopefully that answered some lingering, clarifying questions that you've had about some of these initial figures, the building blocks of geometry. Have a good rest of your day.